finally, we're going to get to hierarchical clustering, which is another form of clustering, but different. And this works off a distance matrix. So we'll use our same data here, and we'll compute distance of X, which computes a 100 by 100 pairwise distance matrix, and we make a call to hclust. So hclust is the tool that we use for doing hierarchical clustering. So by now, you've become pretty adept at R. If you want to find out more about hclust, you just go help hclust, and you'll get help online. Once you've computed the fit, you know how to print it out. And if all else fails, if something else you'd like to find out, searching the web is a really good idea. These days, if you search the web for R-related queries, tons of stuff comes up, and you can often find out all kinds of interesting information. So here we ran hclust with method equals complete, and we'll just plot the data. And it plots a dendrogram that shows the clustering. So if you recall, this is a bottom-up clustering technique where it continuously joins together smaller clusters to make bigger clusters until eventually you get to one big cluster. Now we know there's 4 natural clusters in these data, and from the heights of the arms of the dendrogram, it's evident that there are 4 big clusters here, and these will almost certainly correspond to the original divisions in the data that we created. Complete is how it decides how close 2 clusters are, and what complete does is it uses the largest pairwise distance between a point in one cluster and a point in another cluster. There's other methods we can use. So single linkage clustering, it's called. It's the same call, except method equals single. So instead of looking at using the largest distance, it uses the smallest distance. And it gives you a rather different looking picture. And the 4 big groups that we saw aren't as easily evident in this one. It seems to have found 1, 2, 3 groups, and then somewhere in here is a division into the 4th group. So single linkage clustering tends to find long strung out clusters, because it's just looking at the closest point between clusters, and so you might not get nice clumpy balls like we expect to see in this case. Average is somewhere in between, and indeed the plot for average looks somewhere in between. But I think for these data, I think we probably prefer the method equals complete. So we're gonna compare with the actual clusters in the data again. We'll use a function cut tree, and we'll cut it at level 4. Okay, so that's the first thing we'll do. And so that cuts our original cluster tree. Let's just plot it. Let's get its plot up there again. Here's the dendrogram. So we've cut it at level 4, so that means at the point where there's 4 clusters. So now we're going to identify who's in each of these clusters. And for that, we use the function cut tree. And all cut tree does is you tell it the level that you want, which is 4. The number of clusters you want, it's 4. And it gives you back a vector of cluster assignments. So now we can use the table function to tabulate those assignments with what we know to be the real assignments, which is given by a variable which. And so you get this little table here. Again, the orders are arbitrary here. And so what you expect to see is some big numbers with zeros elsewhere, right? So the big numbers are the 17, 31, 30, and 19. And then the small numbers are the misidentifications. So there were 3 misidentifications here. And we can also do a tabulation and compare it with k-means clustering. And with k-means clustering, there were two disagreements. So both k-means and hierarchical clustering didn't know the true assignments, and they agreed mostly, but on 2 points they disagreed. Now, you can there's fancy ways that you can plot hierarchical clustering trees that actually tell you, that color say the leaves according to the original cluster membership or some other variables. These tend to be rather technical. I actually looked to see how to do this by searching on the web, and even though I was able to do it, it's probably too technical to put in this demonstration, but if that's something you wanted to do, I urge you to have a look. So people have written functions for doing that. What we'll do is something a little simpler. The plot command for dendrograms, for cluster trees, has a labels argument, and we're going to label it according to the original cluster assignment. And if you can see here, you'll see that all these guys down here are 4s, there's 2s, there's 1s and 3s. It's not that clear, but if we had a bigger place to plot, you'd be able to see which of the points were misassigned. So again, use the help to find out more about hierarchical clustering. And again, if all else fails, go and search on the web. And once again, this is a R Markdown document in RStudio, so we can knit it, and then we get a nice HTML document which gives a summary of our results and with any figures we made in one nice document. And we got our figures. This is something you can share with some colleagues or to show the analysis that you've done for them or for the demonstration. So there we go.